Hey, hello everyone, and can everybody see my screen okay?
Yes, but it is in presenter mode.
Oh.
Looks good, Constance.
Okay, thank you. Is it still in presenter mode, or is it?
Nope, it's fine.
Okay, perfect. Thank you. I'd like to welcome everyone to AOAC's Botanical Identity Verification Virtual Forum. This meeting is being recorded and will be conducted under AOAC's policies and procedures. My name is Constance Barr. I am a program coordinator here at AOAC International. I'm going to do a quick run through of today's agenda. And so starting off, we're going to do a welcome and overview. And Katerina Mostovska will give a brief introduction to the initiative. Then Dr. Holly Johnson will define botanical identification and provide background on what botanical identification means within a regulatory landscape. Then Dr. Paula Brown will provide examples of diagnostic techniques and challenges faced with the identification of botanicals, a practical approach. Following that, Dr. Cris Amarillas will highlight challenges with testing botanical material, qualitative versus quantitative testing using a single scientifically valid method versus an orthogonal approach, and will provide framework for further discussion. And then we will turn things over to the group, and Holly Johnson will be moderating the discussion. So I'd like to first give a brief introduction of our presenters today. Dr. Holly Johnson is the CSO, Chief Scientific Officer for the American Herbal Products Association, which is an alliance of over 400 member companies doing business in the natural products industry. Dr. Johnson took a Bachelor of Science in Botany and a PhD in Pharmacognosy with specialization in medical ethnobotany, and was awarded an NIH fellowship for doctoral training at the University of Illinois Chicago NIH Center for Botanical Dietary Supplements. Previously, she served as laboratory director for Alchemist Labs, an ISO 17025 accredited third-party contract testing lab specializing in botanicals. Dr. Johnson has been an AOAC volunteer for many years, serving on working groups and expert review panels in standard setting work for foods, dietary supplements, and botanicals. Holly is a member of the U.S. Pharmacopoeia Expert Committee for Botanical Dietary Supplements and Herbal Medicines, and also the USP Cannabis Expert Panel, and serves on the advisory boards of the American Botanical Council and the American Herbal Pharmacopoeia, among others. Holly has over 20 years of experience in botanical research and spent many happy years giving courses at the University of Hawaii. Dr. Paula Brown is the Director of Applied Research for Natural Health and Food Products at the British Columbia Institute of Technology and holds a Tier 2 Canada Research Chair in Phytoanalytics. She received her PhD in plant chemistry from the University of British Columbia and a Master's of Science in Natural Product Synthesis from Simon Fraser University. She's an internationally recognized expert in methods of analysis and natural products chemistry. Dr. Brown is a fellow of the AOAC International and serves as an advisor to the American Botanical Council and U.S. Pharmacopoeia. Dr. Brown is the 2022 recipient of the AOAC International Harvey W. Wiley Award, the 2021 Norman Farnsworth Award for Excellence in Botanical Research, the 2019 Waters Award for Innovations in Natural Product Research, and the 2017 Herbal Insight Award and the 2017 Neil Towers Award. She has served as an advisor to the Health Canada as a member of the NHP Program Advisory Committee, the Self-Care Task Force, and most recently as co-chair of the Science Advisory Committee for Health Products Containing Cannabis. Dr. Cris Amarillas is the Chief Scientific Officer of Botanicals at Eurofins Food and Feed. She serves as the scientific botanical resource and provides technical direction across food chemistry testing and quality, ensuring continued ISO 17025 compliance. She actively participates in developing methods, troubleshooting, and mentoring scientists. Prior to joining Eurofins, Dr. Amarillas was a consultant for dietary supplements, over-the-counter drugs, cosmetics, and food brands and vendors. Prior to that, she spent 12 years with traditional medicinals in quality and research and development. Dr. Amarillas holds her PhD in chemistry from Stanford University. She is a clinical herbalist, completing 2 certificate programs at the California School of Herbal Studies in Northern California, which she continues to teach at. Cris brings her passion about herbalism, botanical chemistry, regulatory framework, and industry applications to all aspects of her professional life. And I'm going to turn things over now to Dr. Katarina Mostovska, the Chief Scientific Officer here at AOAC International, to give a brief overview of our vision for this initiative. And with that, Kate, I'll let you take over.
Thank you so much, Constance, and welcome everyone. Our Botanical Ingredients and Data Supplement Integrity Program, or BITSI, their stakeholders identified botanical identity verification as the next priority for the BITSI program, and the objective of today's virtual forum is to provide background information on this topic and highlight challenges and gaps that we should address and establish framework for this new AOAC initiative, which we are hoping to get enough support for and launch soon. And as Constance introduced, we have 3 wonderful ladies who will give presentations and lead the discussion today. So Holly, please take it away.
Okay, great. Thanks so much to both Kate and to Constance for inviting us to be here today. So happy to be here with my esteemed industry colleagues, Dr. Brown and Dr. Amarillas. All of us been involved with AOAC and botanicals for quite some time. So we are here to hopefully, like as Kate said, kind of get this discussion rolling as to how AOAC and BITSI in particular can kind of play a role in helping stakeholders develop, more standards and better risk assessment around botanical identity methods. So I'm going to go ahead and share my screen. And you guys, I'm just here today to do, or at least on this moment, to do kind of a quick introduction in terms of just a quick kind of refresher in botanical identity and kind of why it's important in an AOAC context and what we hope to do here. So I'm going to share my screen. Sorry, 1 second here. There we go. Oh, shoots. Okay, sorry about that, you guys. I have a new computer, so it was not letting me share my screen right away. Okay. So again, I am Holly Johnson, the Chief Science Officer for the American Herbal Products Association. And today I'm going to just do a quick introduction before turning it over to my colleagues to talk about challenges in botanical identity testing, kind of leading up to what we might be able to do here in BITSI. So again, just kind of a quick preview of what we're going to talk about today. Regulatory compliance here in the US, how that works with botanical identity and setting specifications and selecting fit for purpose, scientifically valid methods for our botanical identity testing platforms. So I think you guys know, most of you, I'm an ethnobotanist, pharmacognosist, and so I can't help myself but talk about plants in history. And just to reframe here, that plants and botanicals, they've been consumed by humans as medicine for millennia. Here, even in the United States, this is an outtake from the 1851 United States Pharmacopoeia, as you can see, filled with all kinds of plant medicines. This is kind of a picture of maybe a way that we used to get our botanical tonics, our botanical medicines. And these days, it tends to look more like this, at least in the United States, right? This is a shelf down at the local Erewhon in Venice, I believe. But basically, globally, herbal products and medicinal plants fall into a variety of regulatory categories and schemes. So, AOAC is a global organization. We make international standards, but I'm going to talk just a little bit today about the regulatory scheme for botanicals here in the United States and how botanical identity specifically is treated there. So, again, not to belabor anything like this, but very basic regulatory structure here in the United States. The Dietary Supplements Health and Education Act passed in 1994 called DSHEA. This is a federal statute and kind of defines and regulates dietary supplements. So this is the structure that we all kind of work in if you work in the field of botanical dietary supplements. And before 1994, herbs were kind of lumped in with conventional foods. So after the final rule came out in 2007, seems a little crazy that it took from 94 to 2007, but maybe in retrospect, not so much. Our regulators are busy. So anyway, this final rule came out in 2007. This is actually a cool document that's on my organization's website, AHPA. It's AHPA.org. You can go on there and find this document that we published back in 2007, but basically it goes through the differences between at that point, existing food regs in 21 CFR Part 110 and Part 111. One of the biggest differences is kind of what we talk about here in Part 111, where Subpart E 11170 requires the establishment of specifications, very specific specifications for identity, purity, composition, and strength, as well as on limits of those types of contaminants that may adulterate. So what we're, going to focus on in this particular BIDC initiative is identity, and specifically botanical identity, as it's quite a bit more complex than other things. But again, just giving a little bit of framing of the regulation and how it treats botanical identity. So first of all, it requires establishment of specifications for identity as well as other things. Okay. Specifications are going to be specific to each material, right? If you're sourcing different materials, you get an ingredient C of A. A lot of times, people don't pay attention to the methods, especially for identity, right? You might go down and look on this C of A, make sure that the material is passing for, say, heavy metals limits or microbiological limits, that type of thing. But the methods that people use for botanical identity are super, super important to support those specs. So always take a look there. And again, if you're a manufacturer that's going to buy an ingredient, never, ever, ever set a specification, especially for a botanical identity, but really for anything, without saying what examinations, what methods are going to be used to support that spec. So continuing on in Part 111 here in kind of our regulatory roundup, 11175 also says, so in 11170, we just mentioned you must set a specification for identity, among other things. Here in 11175, you actually must determine that your specifications are met. What do you do to make sure your specs are met? It says right here that you must use an appropriate scientifically valid method. They give some examples here of what they consider to be appropriate scientifically valid methods, or at least some tests or examinations that could be appropriate and scientifically valid depending on your material. So you'll see here some really common ways that we evaluate botanical materials with gross organolepsis, macroscopic or microscopic analysis, chemical methods, and then this kind of last part here, or other scientifically valid methods. So there's also this discussion of what is scientifically valid, right? So Part 111, again, the part that of the CFR that's talking about dietary supplements and dietary supplement GMPs, we've got 111.320. So it actually requires that not only that you set a spec back in 11170, use a method of evaluation in 11175, but here in 111.320 requires that you actually have to verify that your lab methods are appropriate for their intended use and that they are scientifically valid. So while, first of all, we can have a quick discussion of why didn't they use the term validated in this particular regulation? And I think probably some of you on this call at least have heard this before, because especially in an AOAC context, most of us are analytical chemists or have some familiarity with that type of thing. And we say, why? What's the difference between scientifically valid and validated? Why wouldn't you just validate the method? Well, of course, if it was a quantitative HPLC method, you would. So where it gets a little tricky is with some of those other methods that were mentioned, such as organolepsis, macroscopic and microscopic evaluations. Many of those are qualitative, and that tends to be some of the methods that would use to be support specifications for identity, as opposed to specs for, say, limits on contaminants or determination of specific markers in the composition. So what the rule makers decided back in the day is that the word validated would apply to things like I just described, like a quantitative HPLC method, which we all know very well how to validate, right? In accordance with either ICH guidelines, FDA guidelines, AOAC, Appendix K guidelines, United States Pharmacopoeia, General Chapter guidelines. So there's plenty of guidelines that can tell us how to fully validate a quantitative method. But getting to what is scientifically valid for a qualitative method is a little bit of a different discussion. So that's one thing. Again, just an example here of some standard setting organizations, including the AOAC, which are places you can go to either help you set specifications like the American Herbal Pharmacopoeia monographs, or to select scientifically valid appropriate methods, which they have available in AHP monographs as well as in United States Pharmacopoeia monographs, and of course, as in AOAC's OMA and elsewhere. So here at AOAC, we tend to be more analytical chemist-based, right? And we understand what scope means and what fit for purpose means in terms of, again, quantitative determinations. So if we look at this this is an example I use often when we are talking about quantitative type specifications and support for them. Here's a method somebody brought to me that they said they were using to support their quantitative specification for resveratrol in a botanical material. I'm sure many of you maybe have seen even me show this slide, but you can see right away that this is not a fit for purpose method. If you read the title here, this method was developed and validated, great, but it was validated for a different purpose, to determine the resveratrol in human plasma, so in blood samples. So completely different matrix, completely different thing. Scope really matters. And again, that's for a quantitative determination type method, right? But just as an example of what I mean by this. And so if we look at this label here of a finished product supplement, we can see a bunch of ingredients there, right? Including a resveratrol ingredient for which AOAC has a method for potentially. The United States Pharmacopoeia has a monograph for green tea extracts. So we can find methods from our traditional standard setting organizations and monograph producers for methods for kind of common materials. But once you mix these things all together, we realize that you might need a matrix extension, validation, verification for a complex finished product. We're talking today about botanical identity and not necessarily even in complex finished products, although that is part of the thing that challenges stakeholders with botanical dietary supplement identity specifications. But just use this as an example for you guys of that scope really, really matters. And even if some of the standard setting organizations have really well validated methods for some things, scope matters, and appropriateness and fit for purposeness of use. So how does that fit into botanical identity, right? How are botanicals actually identified? I can't see you guys all on the Zoom, but I bet at least some of you know who this guy is, one of my favorite humans in history, Linnaeus. So many of you maybe even have only heard of him by seeing an L, capital L period after a botanical name, a Latin binomial. But again, this is Linnaeus, Carl Linnaeus. He was a Swedish botanist, quite a famous one. And he came up with kind of our modern system of nomenclature of how we name botanicals with Latin binomials. Linnaeus was a really quite famous botanist, and in Sweden, they really revere their botanists. I always have to say, because I'm an ethnobotanist, that he was one of the first kind of modern ethnobotanists going up into the Lapland territory in the Arctic Circle of Sweden, studying the Sami reindeer herders pictured here. And Linnaeus, in Sweden, they revere their botanists so much, they put them on their money. Here he is on a 100 kroner bill. So anyway, a small aside there, but the point being here is that Linnaeus has come up with a modern system of identifying botanicals. So how do we do that? How do we make these different taxa, really, right? How do we perform a test and it comes back a result and says it fits into this taxa? Well, botanical identification is the most definitive way to do this is by morphology, right? And this is how, back since the times of Linnaeus, botanists and others have identified plant species. Generally by macroscopic evaluation of the morphologic characters. So characters like all kinds of different things, leaf venation, leaf patterns, flower part numbers and whorls, all kinds of different things. But mostly the system was developed from looking at the plants in their whole form, right? How the leaves are attached, how the flowers are attached, how many of certain parts, this types of things helps define the species and kind of which taxonomic bucket these things go into. So I feel like this is a little bit out of order of what I was going to present today, but I'm going to just keep raging along on this slide here. This is a slide from an AHPA AHP course that we teach on botanical identity. And so I thought I'd throw a couple of these in here to kind of show the different types of tests that are generally used. As I just described, the most definitive form is using morphology, and that's what from Linnaeus on, botanists have done to actually identify a plant, 2 species, say. But there's some other types of physical tests, chemical tests here, the list of them as examples. There's also some molecular tests that can be done, and on here is not listed is organolepsis, which can also contribute to botanical identity. So I want to just give a couple examples of what do I mean by a physical test here and what can you look at for macroscopic characters. But you can see here all kinds of different macroscopic characters, from the size of the leaves, the size of certain things, the shape of the leaves, the leaf margins, their base, their apexes, to surface characters of the leaf coverings, tastes and smells. That goes into like organolepsis. All kinds of things in here listed here that can be used and that are kind of macroscopic or morphological characters that are generally used in identification of botanicals. I want to throw up one other slide from our course here, where we give a 2-day course on botanical identity methods, and this is just a couple examples, but really just to give you kind of an idea that each testing platform, this is molecular, has its pros and its cons, and also has to be evaluated on the basis of what is the material of interest that you are trying to establish identity for. So another thing just to add here is, when do you identify commercial samples? And again, this is kind of part of the challenges that we're faced with now, is oftentimes in industry, we start contacting our botanical materials towards the bottom of this list here, potentially at the extract stage, but it may be at the powdered plant material stage and at different stages. And so again, just to reiterate that when a plant is in its whole form and you can look at morphological characters, that's the most definitive way of identifying the botanical species. And as you get more processed materials, whether it's powdered or powdered crude material or a powdered extract, or further processing has occurred, the reliability of the results gets potentially less. And this is where, when you get more processed materials, you might have the need to take an organoleptic approach where, the morphological features are gone. So we might need to do a combination of approaches to really get enough confidence to make a solid ID in the absence of any morphological or anatomical characteristics. So again, the main way that things are identified, the most definitive way that plants are identified is through gross morphology. And as materials become more and more processed, all these other methods, including chemical, are kind of proxy methods, right? So here's a slide just kind of showing a list of some of the challenges that come into botanical identity testing. So as was suggested in that last slide, our supply chains have been globalized. A lot of our herbal manufacturers, they don't actually have access, or they're not vertically integrated. They don't know their farmers or their aggregators or their suppliers or their wild harvesters, which is fine. There's not always a need to, as long as you have confidence in your supply chains. Some manufacturers purchase powders. They never see the actual plants. So that's kind of a supply chain type level reason why we are forced to use other methods than gross morphology to determine botanical identity. Some of the other things that can happen are just due to the nature, again, of the globalization of the supply chain. So we can get hybridization. If you have a species of plant that, say, was native to Europe, it's only been grown in Europe, but you bring it to the United States to try to cultivate it, maybe it then here in the United States will start hybridizing with a closely related species that it never came in contact with in its native population range. So you can get some hybridizations, which can also cause interference with an established genetic method or a chemical method potentially. So those things can happen and are challenging. There's also just the blatant, just gross variation in natural populations of plants. And so this brings up things about how much variation of nature do you have to sample to know that you have a representation or a representative sampling of what is your taxa or your thing that you're trying to identify. All kinds of things with cultivated crops that might, environmental conditions as changes in cultivation happen, or even changes due to climate change in natural populations can influence the chemical composition of plants. So this can be really challenging when you're using chemical methods, right, to determine your identity, as these chemicals are variable and can occasionally be variable and changeable as you cultivate or sample in different ways, or as climate changes, even in a single geographical region. We also have some real big challenges with reference materials in terms of if I want to set up exclusion species, and I'll hand this over to Cris and Paula to talk a little bit more in detail about these things, but I could call around to a bunch of manufacturers, a bunch of growers, suppliers, and I can probably get 20 different samples in a day or two of St. John's wort. That's authenticated to a greater or lesser extent, but of authentic St. John's wort material, Hypericum perforatum. If there is some type of known adulterant or sister species that tends to grow in the same area of cultivation or collection, that may need to be included in the exclusion species as you're determining your botanical identity and developing and validating methods there. What is harder to find for the purposes of method validation are the actual sister species or potential adulterants or confounding materials. I can't call up 20 manufacturers and immediately get samples of, say, Hypericum hirsutum. So not only certified reference materials or botanical reference materials of the species of interest and the species in commerce, but we also need reference materials for the quote, like the out species. And those can be more difficult to procure, especially ones that might be representative. So again, these are just some of the challenges that come up in botanical identity testing. And just a reminder that morphology, gross morphology, is really the way to determine the identity of a species or a taxa, and that these chemical methods that are largely used can be really useful, but they are proxy methods, really. Again, just a thing here to show that some things are less complicated than botanical identity. If you want to test for a heavy, for compliance with a heavy metal specification that you've set as a manufacturer or an ingredient supplier, or a microbiology or mycotoxin type specification, these methods tend to be less complex, right? And tend to be more applicable to different types of materials and that type of thing. So your specification for everything beyond identity even is going to be linked to your method of evaluation, but some specs are easier to support than others, right? And less dependent on the form of substance, whether you have a root versus a powdered material or a powdered extract even. So again, morphology or the general physical examinations, they're just not fit for purpose for these highly processed or extracted materials that most of us are dealing with in commerce. So this is something that AOAC is really expert at, right? Selection of appropriate fit for purpose testing methods, development and validation of those methods. So I think that's why we're talking about this stuff here today. So just threw this in, one other reminder of the differences I kind of showed before. AHPA did a comparison of part 110 to 111. Some of you guys here at AOAC probably worked with the Cranberry Group, and this was when we had a stakeholders forum for strategic food methods, I think it was called. There was a Cranberry Group over there that I worked with. I think I was the chair of the working group or the expert review panel. And the people from Ocean Spray were just flabbergasted about this botanical identity requirement under Part 111. They're like, what do you mean you have to prove it's a cranberry? And I think that comes from, just the long history of Part 111 and how foods are dealt with. And really, if you hold a cranberry in your hand, pretty much most of us might be have the expertise to identify that as a cranberry, right? And so as food and botanical materials tend to be used cross functionally in both regulatory systems, a lot of the ingredients that you might be sourcing, the suppliers are used to supplying to the food industry, and they may not be aware of this requirement for a botanical identity verification and specification. So I threw this in just again, even if you have a fully validated method, this is real, well known to you guys here in the AOAC community, and thanks to Alchemist Labs and the HPTLC Association for this slide. But just a quick here on, this is all the same material that you see here in lanes 1 through 15. The original material was extracted with all these different solvents. So again, you can have a validated method, but it needs to be fit for purpose for the type of thing that you're looking at, or you can get quite different results in a chemical method. Okay, so one of the last things I wanted to say to you guys today, an introduction kind of to the regulatory landscape that we're in and that we're trying to address here at AOAC with the BIDC program and botanical identity, is botanical identity is the only specification that you must actually conduct at least one appropriate test or examination to verify the identity of any component that you will use as a dietary ingredient. I know there's a lot of words on this slide and that's too many words for you to read, but I put them all here because I think it's kind of important to remember. Any of us that are manufacturers, of course, are very familiar with this, but basically you source an ingredient from a supplier, you receive that ingredient. If you have done all these things down here, where you have qualified the supplier by establishing the reliability, again, just basically establishing your own very strong supplier qualification program, ingredient qualification program, you can do that and get to a place where you document how you've qualified the supplier, qualified the ingredient, and you are not required to do every single test. You can actually use, as it says here, you can rely on the certificate of analysis from the supplier for all of these other specifications, for heavy metals, for microbiome, those types of things. The one thing that you cannot rely on your supplier's C of A for is identity. So again, lots of words on this slide, but just to kind of remind you guys that identity is the one thing that must be actually given a test to verify the identity of the component. You're not allowed at all to rely on the C of A of your supplier. So identity tests are a hot commodity. Whether you use a contract manufacturer or you bring things into your own house, we really need more scientifically valid, fit for purpose identity methods for botanical materials. This is a really cool slide. It looks like I cut off the website on the bottom there. This is from our friend and colleague, Marion Boardley, maintains a really cool website. Marion's a consultant in our industry and looks at GMP things. And so these data, Marion took and made this chart. And I'm so apologize. It looks like it cut off the top and bottom the way I placed this in here. But Marion Boardley's site, she takes all these data from the FDA, and this is, I'm sorry, again, if you can see this top thing. So this is, I believe, 483 violations for the calendar year 2023. And you can see setting specs for identity is 1170E, but also down here in 11170B1, proper identity component specifications. There's all kinds of things in here that relate to botanical identity. So again, just to put this here to remind us that it continues to be something that the FDA is looking very closely at and is sometimes flagged as a violation. So in closing, again, we just talked about a little bit, you guys. I just kind of set the stage for my colleagues who are going to give you a lot more data and examples of kind of these challenges in botanical identity testing. But the main things to keep in mind are the globalization of the supply chain and the way that our regulations are here in the United States, and kind of just the way we do business has made it challenging to establish botanical identity and to find the appropriate scientifically valid methods of evaluation to support identity specifications for all these different reasons. And again, chemical methods are the ones that we're kind of a little bit more expert at here at AOAC. Obviously, there's all kinds of microbiological expertise here too. But I think I went into a little bit of kind of what might seem like off detail there about the regulations, just to frame for us our discussion today that the same validation parameters that are laid out in Appendix K that apply to quantitative determinations that we're so used to dealing with here at AOAC are not quite enough for what we need to do for botanical identity. They're just not applicable. And so I think that was just my lead in to kind of the regulatory setup that we're facing here in the US with botanical identity, some of the challenges we have, and really what AOAC's recognition that within the dietary supplement space, botanical identity is a big challenge for stakeholders. So what we've had is the stakeholders at BIDC say, hey, we want to do something with botanical identity here at AOAC. We want some initiatives. And so I think kind of where we want this discussion to go today is what can AOAC BIDC do? We want to leave here at the end of the session today with some advice from you guys and answer some of your questions on kind of what are the deliverables that BIDC could tackle next as a standard setting organization to help the stakeholders in the dietary supplements industry have those resources in scientifically valid, fit for purpose methods to support botanical identity specifications. So I am going to turn it over to my esteemed colleague, Dr. Brown, and after that, Dr. Amarillas, for some more data-heavy kind of discussions of some of the pitfalls and challenges with botanical identity. And then we're going to have a really robust discussion, and we want questions from you guys. So please, as things arise from what I've said or what my two colleagues say coming up, please do. I think you can go ahead and put your questions into the chat and let us know what issues are facing you and what you see as something being helpful as far as a deliverable or initiative that we can include in this section of our BIDC work for botanical identity. And I think with that, I will hand it over to my colleague, Dr. Brown.
Thanks, Holly. That's great. After seeing, your slides getting come off, I'm a little nervous here. Like, oh, I hope mine line up properly. I just want to draw people's attention to the chat because Marian, very kindly put the link in there. So if you want to look at her data of the FDA violations, warning letters, it's really interesting to look at. She does a fabulous job. But the link's in there. So I tried to start my video as well and it didn't work. Is it just blank for everybody? Yeah.
Yes.
Oh, goody.
So Paula, you're not sharing your screen,
Oh,
right?
there. I am there.
Okay, we see
I'm
you,
about
but
to share my screen. Okay.
okay, great.
I hope this works. Okay, can we see this? Hopefully.
Yes.
Yep.
Okay, so it's always a little bit awkward with this because, of course, I can't necessarily see the people or anyone here and what's going on, but I will do my best. So I was asked to talk about botanical identification from a laboratory perspective. To my mind, and in the way that we do our work, that's really talking about machine learning and analytical methods. So I gave myself a little subtitle because I always have to change the title of every talk I'm asked to give. It's just a thing. But I just wanted to talk a little bit about this. And to set it, I started with some key considerations. And this is a little bit redundant of some of the things that Holly has said. Oops. Once you leave that plant morphology behind, you're using, and I like the term proxy. I said surrogate, but proxy is more accurate. Again, the more highly processed the material, the fewer options are available. You've taken away, macroscopic techniques, visual identity, potentially microscopic as well. There are very few chemical methods that include identity as part of the fitness for purpose statement. I think that's one of the biggest challenges that we face is that there are a lot of analytical methods out there. You can look at things like the USP. They have all these great analytical methods, but that's not for identity specifications. And so that definitely poses a challenge. What exactly is a botanical reference material? Right. I think that's a discussion we're going to have. What does that mean and from a practical standpoint? And how do you validate an authentication method? I think that if you don't look back in history, you're doomed to repeat the mistakes. So I pulled out this. This is from April 20th, 2010. There was a working group for validation of identity methods for botanicals. I can see from the people attending, a lot of people were a part of this group that are on the call now. And the purpose was to put together a generic validation protocol to evaluate identity methods that would be independent of the method itself. And so some of the things that were discussed in this working group was to define what an identity method is actually supposed to do. What is the purpose of the identity test? Are these tests used for inclusion or exclusion? And it was discussed that industry was mainly interested in inclusion. It was about identity, not about amount. Which comes into play. Determining the point at which an identity test fails becomes a crucial part of your validation, and this is still true. For validation models for qualitative methods, at the time, AOAC had just been revising their microbiological methods, and at the time, the chair of the statistics committee, Paul Welling, provided an overview of what they called their probability of detection model. And so our question as a working group was, could this validation model be adapted for qualitative botanical identity methods? This moved into an ERP, that working group, but at the time there was also a lot of stuff out there in the literature and inside laboratory management. Actually, in 2005, if anyone wants to dig back in their archives, there was a really multi-page feature about traditional Chinese medicine. And I just highlighted one piece here, and that's that, they discuss that the ancient art of TCM is being recast into modern scientific terms. By chemical analysis, fingerprinting techniques, and chemometrics, techniques that can apply to many complex foods and agricultural samples. So this idea that we were going to have to move into a new way of looking at data was well known even then. For the expert review panel for botanical identification, again, the sort of purpose was restated as to establish guidelines for validating botanical ID methods, applying that same sort of rigor that we apply to quantification methods. A brief, we had an explanation of our thinking behind the definitions. I pulled this from the meeting minutes, yeah, weirdly, but it talked about botanicals being complex materials that can't be characterized by one or two components. We discussed that suitable methods would have to consider all the chemistry or genetics by using fingerprinting or genetic PCR type techniques, but weren't going to tackle PCR at that time. That any unknown material would have to be authenticated by comparing foods and agricultural samples. So this idea that we were going to have to move into a new way of looking at data was well known even then. For the expert review panel for botanical identification, again, the sort of purpose was restated as to establish guidelines for validating botanical ID methods, applying that same sort of rigor that we apply to quantification methods. A brief, we had an explanation of our thinking behind the definitions. I pulled this from the meeting minutes, yeah, weirdly, but it talked about botanicals being complex materials that can't be characterized by one or two components. We discussed that suitable methods would have to consider all the chemistry or genetics by using fingerprinting or genetic PCR type techniques, but weren't going to tackle PCR at that time. That any unknown material would have to be authenticated by comparison to an accepted botanical material, but authenticated and accepted were also in quotes, and I don't know if we ever actually came to any real definitions around those. And with fingerprinting methods, statistical approaches such as ANOVA, PCA, and SIMCA would be used to establish those yes or no answers. These methods would provide a metric that could be then evaluated by the probability of detection model, and it was suggested that the probability of detection should be reconsidered as a probability of rejection, meaning how much adulteration is tolerated before a botanical is rejected. At the end, it ended up being the POI, probability of identity, not probability of rejection. That got rejected. So that's where we were left with that. And so this, of course, this work was published. Thing is like not loving me at all. Oh my goodness. Don't move on. But really, even at that point, we knew that it was going to come down to chemometrics, or you could call it machine learning. It's really using algorithms and statistical models to analyze and draw inferences and patterns from data. And so since I knew that Holly was going to talk about taxonomy and botany, I decided I would throw in my taxonomy of machine learning. Probably this isn't anything new to anybody, but basically you have different types of machine learning. There's supervised learning. So this is like the kind of machine learning where the model is trained on labeled data. Right. So the goal in supervised learning is for to create a map using inputs and outputs, and then use that map to predict the output for a new piece of data. Right. So supervised learning is, commonly used in classification and regression. So that would be like your linear regression model, your decision tree, random forests. Of course, most common would be partially squares discriminant analysis, so PLSDA, and classification models. Then, of course, we have the unsupervised learning. And unsupervised learning is where you're trying to get the model trained on unlabeled data. So the goal is to find patterns and relationships, but without giving the model any prior knowledge about what it's looking for. So it's kind of just throwing it in there and hoping, seeing what comes out. And so unsupervised learning is commonly used in sort of clustering, dimensionality reduction, maybe anomaly detection. So most of what you see in our field would be clustering tasks. And so this is where the goal is to group similar data points together based on their features. And again, without having any prior knowledge to those groupings. So this would be your hierarchical clustering, your principal component analysis, your soft independent modeling of class analogy, which we call SIMCA. And, we're horribly at, throwing around all of these different acronyms all the time, but eventually you sort of get familiar with them. And then the last type of machine learning would be reinforcement learning. This one, this is sort of how AI-driven systems learn through trial and error from feedback on actions, right? So really, it's kind of like the science of, I think, decision making. It's like, how do you learn an optimal behavior in an environment to obtain an optimal reward? I don't think this is appropriate at all for botanical identity. So we're just going to forget about that. And please, for the love of God, don't use GPT chat or anything to decide whether something is really the right identity or not. I'm so tired of everyone keeps saying, oh, well, let's check GPT chat. Oh, it's terrifying to me. Anyway, so I digress. So I just wanted to give that brief overview of kind of machine learning, but back to where we were with the probability of identification. As I said, this was, oh my goodness, what? This thing, okay. It disappeared, there we go. So the probability of identification, this was published in 2012 by Jim Harnley and Robert Labud. So this is a statistical model for the validation of qualitative botanical identity methods. Okay, so I want to talk about this because, of course, if we have this, then the question is why are we doing this again? And I'll give you an example of one of the ways that it was challenging. So the POI, or the probability of identification, it kind of works in two parts. First is inclusivity and exclusivity. And the second part is you select levels and you establish your confidence. So for our experiment, in part one, we decided to inclusivity, exclusivity. We looked at, for exclusivity, we included different species, different plant parts. And in part two, we looked at identity specifications for pharmacopoeias, and we found that they basically ranged. In this case, we were looking at echinacea, that 97 to 98% E. purpurea root material, not more than 2 to 3% other. We decided to go with the 98% purpurea root material and not more than 2% other as the specification for identity for our part two. When you go into part two, you set it up so that you look at what is your worst acceptable material, which is your SSTM. I don't even remember what those acronyms mean. It got very complicated and word jumbled. But basically that's saying that if you have 98% purpurea roots and 2% other, in this case we had angustifolia roots, that would be acceptable, and that would be the minimally acceptable amount of adulteration in there. Then you set what would be your best not acceptable material, which is sort of weird, which is your SITM. And so in this case, we basically said, well, okay, if you had 90% purpurea roots and 10%, that would be not acceptable. So by selecting these levels, when you follow this POI statistical model, you need to do N equals 60 analysis, and that would allow you to have 2 failures, okay, overall. And so the validation itself is based on the rates of false positive and false negative that you end up with. So we did this. We started our POI 1. We actually acquired Echinacea purpurea roots, aerial parts, Pallida, angustifolia roots, aerial parts. And you start with just making like a simple, we started with a simple SIMCA model, and we would model those E. purpurea roots versus, for example, in this case, we have the E. Pallida roots, and we say, oh, look, it doesn't look the same. And we do this with each of them and generate these models and say, okay, this looks great. And then we decided, okay, well, then we'll look at some composites. So we took the adulterating material that was the least differentiated from the target to make it as hard as possible. And we made composite materials. And again, it's not perfectly linear, but you can see that these are easily differentiated. And we thought this is great. We did an N equals 5. We thought 5 sample replicates was reasonable in statistics. And to begin with, because this is just step one. And then we even did kind of like a little mini validation in that we were sort of doing a test of our model. We set a calibration set of ePropria samples. We had a test set of Propria samples. They all grouped nicely together, and everything that was a mixture came out separately. So this is the Q residuals versus the hoteling. And this made us feel like we're golden. This is going to work great. So we can move forward into the lovely n equals 60. And then we did our n equals 60. And this is what happened. It got really messy. That's basically what happened. So basically from the FTNIR data we were using, the botanical identity model that we created failed to differentiate 98% from 100%. Like we couldn't get that kind of sensitivity. It looked like we could when we did 5 samples. But the more samples, the more of the inherent variation we were capturing in the model. And so like the fuzzier it got and the more difficult it got. And so at the end, really, all we could really determine is that we could differentiate 90% from 100%. So our detection limit was really like 10% of the not target material. We went through a whole lot of different diagnostics. I don't know why, because it was pretty obvious what happened, but, we do these things. So, we did, looking at the calibration versus test sets using the hoteling and Q residuals, using Y residuals, Y predicted. I mean, there's a lot of different diagnostic tests that you can do to establish whether your model is robust. But the bottom line at the end of the day, really is what it comes down to, is that this model was unable to capture that inherent variation of the population. And so you really need to make sure that you add that kind of variation into the model in order for it to be responsive, right? Otherwise, this doesn't work. And so basically, the more samples we did, the worse it looked. Wasn't ideal. We also did a few other different tests, and I bring these up because we're going to be talking at some point about validation protocols. I'm doing significant factor analysis. So this is can be determined using like ANOVA PCA or ASCA, which is ANOVA simultaneous component analysis. And basically, you can look at different factors and evaluate whether they have a significant contribution. And of course, the lot factor was significant. I mean, anyone who works with plants knows that, from plant to plant, even in the same, group can be significantly different. I always think about that, experiment you do with little kids in elementary school where everybody has like an orange and you eat a piece and then you try a piece of your neighbor's and it tastes totally different, even though it's still an orange. Plants, they're great. They're awesome. We also compared PLSDA to SIMCA. And so this is a whole bunch of, this is the data for SIMCA and PLSDA. We looked at things like, sensitivity. So that would be like your true positive rate. So that's basically the ratio of the true typical samples to the predicted typical positive samples. And then, of course, specificity or selectivity, which would be your true negative rate. And as you can see with SIMCA, the sensitivity and the specificity is really good up to about 95%. So I would say maybe 10% isn't where the limit is. It might actually be 5%. But that once you go to 2%, you're only getting about 90% confidence. I guess it's actually 0.89, 0.89 confidence. And then when you look at the PLSDA, while it does have the same sensitivity as SIMCA, it has much lower specificity and efficiency as a model. I just, put in a couple little definitions down here because MCC isn't commonly used, but it's a correlation coefficient that measures a model's ability to predict. And the kappa coefficient, which I always find kind of cool, is measures like if the agreement between the predicted and the known outcome occurs more than random chance, right? Like, was it just a random prediction or does this have some kind of significance to it? I think these are some of the things that we're going to have to think about when we start making guidance and recommendations on how we validate these models, if this is going to be, really used in a practical sense. Performance quality metrics was also a part of a guidance document. I think I saw Nandu here from USP. So if anybody has questions, hopefully he can jump in on that. The USP proposed a guidance on developing and validating non-targeted methods for adulteration detection. Now, this isn't necessarily the same as identity, but a lot of the same principles apply. Unlike POI, where the standard cutoff was like 95%, to accept or reject the model. It didn't have a standard cutoff. It would have to be, set up based, I would think, on your specification. The challenge is the sample size requirement, is dramatically smaller than the POI, which is good. But they didn't actually make a specific recommendation other than saying that the sample size should be larger than 3 for each adulterant. And for the validation set, they recommended 3 samples for each adulterant at 3 levels. And I would just remind you, though, that when we did 5, our data looked really good. Right? So I don't know if 3 is actually enough or not, right? So that's one of the questions. And I think also it's going to be challenging because it's really going to be on a case-by-case basis with botanicals, because it really depends on how distinct your adulterants are, or how, what your particular challenge is for identity with that actual ingredient, right? If the only potential adulteration might be, different plant parts, it may be easier. I showed a comparison of PLSDA and PCA, so I just wanted to also mention that while there are lots of different chemometric-based approaches to authentication or different algorithms you can use, it's pretty much been decided that those discriminant methods don't do a very good job of authentication because they don't properly classify any new samples. Like, for example, when I talked about it being supervised, like with PLSDA, you have your samples, you say, okay, you're telling your model, this is what Echinacea purpurea is. And the model is built on knowing that's Echinacea purpurea. So whenever you introduce something new, it really struggles to deal with that new data. So it's more about classification, not authentication. And so in dealing that, you're left with fewer options if you're taking away all supervised models. And what you're left with is the unsupervised. And so we sort of looked at what options are there. So you've got principal component analysis, where your diagnostic would be Q residuals versus hoteling. And then, of course, there's SIMCA. SIMCA has the same diagnostic because SIMCA basically is a kind of a modified version off of PCA. One other option that we found was called a moving window PCA, where your diagnostic was standard residuals. And so we decided we would compare SIMCA and moving window PCA. I moved away from Echinacea at this point. Echinacea's it's fun, but I got tired of it. So we decided to move over to Golden Seal. And I was trying to pick botanicals, by the way, for which we'd already done quantitative validation models. So I had also had something external to compare it to. But we had different materials we gathered, Golden Seal samples, some of the common adulterants. So we had yellow root, Oregon grape, Chinese gold thread, and yellow dock. I'm not going to try to say the botanical names. I will leave that to Wendy or Holly or other people that are around. And so we went through the process of developing the SIMCA model. Again, we were using FTNIR data. One of the reasons I kept using FTNIR is that it, at the time, was really a technique that was being promulgated as what was going to be the standard for identity when the identity rule came out. And, they started talking about it being the gold standard kind of even really before there was any published validation models or examples of this working. And so I was kind of keen to see if we could find a way to make it work. So the SIMCA model with the FTNIR data identified the adulterants as not Golden Seal. That was really simple. So identifying things as Golden Seal or not Golden Seal, pretty much straightforward. And you can find this data. It was published in 2018 in Phytotherapeutics. So this is like old work. The Q residuals versus hoteling for the composites basically showed us, we used yellow dock because that was the one that came closest to it. So we always try to pick the most challenging adulterant for the data set that we have. But basically what it came down to was we really could only achieve a detection limit of about 15 or 20%. So, if your specification for identity is that it's Golden Seal and not more than 15 to 20% other, then you're golden with this model, right? If you need something a little better than that, then this is going to be a problem. We decided to try the moving window PCA. And so in the moving window PCA, you set windows in the spectra and you build a PCA model per window. So basically you're doing like PCA, PCA, PCA over and over and over and over again. And when you do that, you look at it, and what you're looking for in your reference in this case, golden seal, is you're looking for an area where that residual is 0. So you have a blank space. And then ideally, of course, your adulterants, that same region, as you can see here, is not blank, right? And so then you apply that PCA model. Oh, I don't know where my thing went. There we go. PCA model to the unknown, and then you check those and see where it fits. And so when we go through, and again, we used our Crispus against the golden seal, and we did our theoretical composites, we basically, got down to about 10%. So you could easily detect still that 10%. So this was better than the 15 that we saw previously with a Simca. So it did seem to be a more sensitive model using the same data, but it might not still fit your need. Right, so it's really going to come down to what specification you're setting for your identity, right? Just so that people don't think I only use FTNIR, we also used A-team, so the absorbance, transmittance, and fluorescence excitation emission matrix. So this is kind of a interesting approach. You do get very different data. So that was really fun. Again, we acquired more materials as well, because we realized once again that we probably didn't have enough. So we had golden seal, yellow dock, Oregon grape, and yellow root again. So this is the pre-processed fluorescence EAM plots. And you can actually just see by looking at them that they're really different. So that's great. That made us really happy. Just by examining that, we could see that there were going to be like fluorophore contours that were distinct between golden seal and these common adulterants. So we decided again to try 2 different models. I guess I like to torture my employees, my team members. But we did a Parafac 1 class calibration model and a Simca calibration model. And in both cases, the golden seal with the prediction of common adulterants as a test set was able to differentiate. In the Simca model, we used 3 principal components, which covered a total variance of about 92% of the variance. And again, it showed prediction of the common adulterants. No problem. Again, then it comes down to, okay, but how sensitive is it? We wanted to know, can these 1 class models, whether it's Parafac or Simca, identify warning talk? We needed to get on to what we're actually going to do as a working group. So I think in closing, I just wanted to throw out what I think are some of the key considerations that we're going to have to really think about. We need to define the scope of the identity methods. The current dietary supplement GMP requires that you perform at least 1 appropriate test to verify the identity of each ingredient you receive. Okay, so that means if you're purchasing echinacea purpurea ethanolic extract sprayed out onto a dibasic calcium phosphate carrier, then you need to demonstrate that the material that you received at your loading bay door is in fact echinacea purpurea ethanolic spray dried extract onto a dibasic calcium phosphate carrier, right? That is the specification and the identity that you have to prove with your methods. So I think that has to be a consideration of something that we have to talk about. Again, I brought up at the beginning, what exactly is a botanical reference material? How do we ensure that our models are built to encompass that inherent accepted variance that we have in botanical materials? Can we do that with a single botanical reference materials? How many is enough? How many reference materials is enough? How many samples is enough, right? If we validate an authentication model, what diagnostics are we use? What's going to be our criteria? And where is that cutoff, right? There has to be a point at which we say this fails the identity test, and that has to be very clearly defined, right? And so we have to consider what level of confidence we need and what kind of detection limits are going to be needed. And I think again, it's going to be on a case-by-case basis with botanicals, but if our goal is to develop some, maybe not a guidance, but a series of guidance documents, then I think these are the different kinds of things that are going to have to be addressed, and we need to figure out a way to provide guidance to people so that as they have their identity methods, they can go to these documents and actually identify, okay, I'm going to need this many samples. These are the kind of diagnostics or validation criteria I have to consider when I'm working with a qualitative model. Because it's really different. It's very different from doing quantitative work. At this point in my career, I'm going to go back to doing quantitative methods. No, just kidding. I love the challenge of this stuff. But I think I'll stop it there. I'm going to stop my sharing. I think that we did some interesting work in the first iteration of a working group in an ERP on botanical identity. But I really feel like what I really struggled with even then was this idea that plants were very binary. So it's like it either is or it isn't, because that's not really how our specifications are developed, and that's not really how plants are in practical terms. So with that, I will hand it over to my esteemed colleague. I think it's Cris is up next. To kind of set the framework for the working group. I guess I don't know if I should ask if anyone had any questions or comments. I wasn't looking in the chat.
I think we'll actually hold those, Paula. Let's have Cris go next, and then everyone please do submit comments to the chat for either Dr. Brown, Dr. Amarillas, or myself. We'll have a good discussion after Chris's presentation. We really do want to involve all you guys here in the discussion. So put your questions in. Thank you so much for that, Dr. Brown. And we'll hand it over to Dr. Amarillas.
Yeah. Hello, everyone. Welcome. Thank you so much to both Kate and Constance for inviting the three of us to present and also just put this call back out to the global community. So, and also I definitely want to thank both of the earlier presenters. Thank you so much for setting this up, Dr. Johnson and Dr. Brown. Thank you so much for just giving us that amazing insight. So this is the call to action. This is actually going to be more of a discussion as we go on. Before we start though, Constance, do you want to send out that first poll? Since this is a little bit more of a discussion and we do have the absolute privilege of doing this in a virtual setting. So we do want a little to bring back in the audience into this discussion.
Can everybody see the poll?
Yeah, it's awesome. Thanks.
Yeah, thank you.
So thinking back on Holly's presentation, we wanted to know out of this whole group, if you are a manufacturer, are you relying on a certificate of analysis or a C of A?
Cris, my apologies. I forgot about this poll question. I kind of gave the people the answer in advance.
Not a problem.
We assume most people know this, right?
All right, I'm going to end the poll.
All right. So as Dr. Johnson explained, there are a few things on your specification if you are within the U.S. regulatory framework that you are allowed to take that information off of the C of A, whereas botanical identity, again, if you are operating within the U.S. regulatory framework, you are not allowed to take off of the vendor C of A or the manufacturer C of A. All right, Constance, do you want to do the next poll? And that will kind of lead us into the next discussion.
Okay, yeah, people can see the poll now. Okay, it looks like everyone has. All right, I'm gonna go ahead and stop this poll.
Okay. All right. Thank you. And so Constance, if we can hold off on the last polling question for just maybe 5 minutes.
Yep.
So again, this is going to be a little bit more of a discussion. If you can just give me about 5 minutes to start laying some of the groundwork. Again, we're going to kind of take this last part of it to be more of a participant-driven discussion. And really understanding just the difficulty of where we were. And Paula, again, thank you so much for giving that amazing history of the original Appendix K and just what AOAC did deliver to the industry, and especially that probability of identity. This is, again, where it came back over the last couple of years and why BITSI is forming once again. BITSI has been formed. This is a kind of a call back to industry what do you need from AOAC, and really reminding everyone that AOAC is an international organization that not just is regulatory driven, but also really looking at the government, industry, and academia. Really thinking about, just the different branches and what AOAC actually represents. So this is kind of bringing the conversation all the way back around to saying that this can be applicable in the US regulatory framework, but also for all of you on the call, really thinking about what are your regulatory structures that you're all operating with. So going back to AOAC as an organization, and how can we serve you? And also, how can you participate in this working group? So adopting some of the Appendix K definitions of what is a botanical. Dr. Johnson Hawley did a great job of defining it and really giving more of that morphological definition to some of these things. And then what did Appendix K define as botanical ID? And you can see in the actual definition, it is morphological, genetic, and or chemical characteristics. And then going back to that yes or no conclusion. And Dr. Brown did such a great job in her conclusion in saying that plants are not binary. And we will discuss this a little bit further. So Constance, next slide, please.
Chris, actually, if you just touch your screen, click anywhere, you should have control.
No, it's not letting me.
You're there. No? Okay, I'll take over then.
Okay, thank you. Okay, so this is basically going back to industry, going back to all of you within the AOAC, or maybe perhaps you're not within the AOAC organization yet, really looking at the challenges of that botanical identity. So for all of these classes of those approaches that are listed in that identity specification in Appendix K, looking at all of those and thinking back to what AOAC really brings to all of us in our day-to-day lives, interacting with botanicals, it is truly that single scientifically valid test. And this approach has worked for many things. In the botanical world, it can be appropriate for some of the botanicals and completely inadequate for others. When you look at botanicals, again, the challenge isn't just a binary yes or no question. It really has kind of this series of hurdles or these series of questions to answer when you come to botanical identity. So are you testing for the genus, species, and plant part, as in the US regulatory framework? Are you just testing to confirm genus, again, without going into the regulatory intricacies of your label? Just really looking at what this working group can bring to all of you. where are we defining these? So is this a test for a genus, species, and plant part, or are we truly just going to the genus? Again, using botanicals as our amazing examples, sometimes this works, sometimes this doesn't. Most chemical tests cannot readily determine species. I gave licorice as a great example. Our colleague over at the National Center for Natural Products Research actually did an amazing study with trying to identify licorice in commerce and using those 3 species that are more readily used in commerce. Some botanicals, such as hawthorn, actually hybridize, and this was something that Dr. Johnson touched upon. Once they're introduced into a different region, they readily hybridize. Hawthorn presents this hurdle for us. And then the last one, sometimes it actually does take a couple of chemical tests, so more of an orthogonal approach. Lavender is that kind of prime example where you can do HPTLC, get down to saying yes, and then you want to do a GC test just to make sure that camphor level is within a certain limit so that you can rule out spike lavender or a different type of lavender adulterant that often gets mixed in either accidentally or intentionally into the lavender angustifolia. So this all is to basically highlight the natural variation in plants. This is not just something that we can control necessarily. This is, if you really think about botanicals as a natural product, this can basically take examples of the growing region, growing practices, and again, as we're all looking at that climatic or environmental influence. So Constance, next slide, please. Before we dive into this one, though, I would like to take a pause and just present that last polling question.
People see the poll.
Yes, thank you.
I'm going to go ahead and end this poll.
And Constance, can you scroll down a little bit to capture the second part?
Oh, okay, can you see it now? If not, I can just read it off.
Yeah, there you go.
Oh, okay.
Okay, so thank you all for participating in these polls. What I find noteworthy is that most of you said that you were using HPTLC as your first and foremost one, and then looking at the last polling question, really looking at more of that chemical approach. So HPTLC being part of the chromatography, that makes sense. So as we kind of launch into this discussion and just, again, this call to participate in BIDSI, trying to really anchor this in relevance, the approach of qualitative and quantitative testing. So as Paula described in her slides, taking on, AOAC has done a fantastic job with really establishing amazing guidance and standards around the quantitative side, both for the microbiological side and as well as the chemical side of the AOAC. It's more for specifically with botanicals, it's that qualitative side that has really been more challenging, especially if you are trying to go within using that yes or no, it conforms, this is truly Echinacea purpurea root, or no, this is Echinacea, could be purpurea, could be pallida, and we still know it's a root, or this is Echinacea purpurea aerial parts. So again, looking at this from the approach of the AOAC Appendix K standards and really coming back at this of what is the next step? How can AOAC serve the industry? And also, how would all of you really like to get involved in this? Because this is still a challenge that all of us are facing. The other thing, if you think about it as well, and this is something that was reflected in all the polling, so thank you again for participating in that. The most widely approaches for identity are more of that qualitative. So organolepsis, which Dr. Johnson hit upon, microscopy, and thin layer chromatography, more of those qualitative approaches. It's hard to set a minimum limit, except for that binary yes, no, it conforms, it does not conform to genus, species, and plant part. The other side that has been challenging is this single versus an orthogonal approach. Are you using multiple methods to determine identity? And then the actual test methods themselves. Some of these test methods, if in the past I've had conversations within our community of using an orthogonal approach, where some of these, even the orthogonal approach doesn't have a true diagnostic feature. So you don't get down to that yes, no parameter. Also with that orthogonal approach, if you think about it being additive, each time you add a layer of testing, is that actually confirming down to your specific plant that is needed for identity? Are you actually truly confirming genus, species, and if it required plant part, or is it just an additive approach to all go to say, yes, this is truly Echinacea as a genus? So Constance, next slide. The other side that was mentioned, or the other piece of kind of this tripod of identity, is that botanical reference. This is truly where plants present, probably from a very quantitative approach, a very difficult challenge. So if you look at the natural variation that is presented in the plants, not only is it a growing region, you can have valerian grown on the East Coast and valerian grown on the West Coast, and they will present chemically different from each other, or they can present chemically different from each other. Or Echinacea that is grown in the Pacific Northwest, but looking at the first harvest versus a second or third harvest. Again, same plant, same species, it could even be the same field, but again, all of those present differently. Growing practices, I specifically have experience with dandelion root. That, second year of dandelion root harvest will definitely present differently from a fifth or sixth or seventh year harvest. Again, that harvest and maturity, the harvest times and the maturity. And then if you look at it, and as plants have demonstrate for us, that genetic and morphologically difference, that divergent and convergence that plants do so well. I did put a little bit of a bullet point just because, again, this is something that over the last 10 years or 15 years, we are seeing that just taking a single approach to identity, this is a challenge when it comes to the supply chain of botanicals. It is amazing, and this is kind of the gold standard of really knowing the farmer who is growing the plants. In our global supply chain, sometimes that is a hurdle in and of itself. So looking at your supply chain, again, if you're within the US regulatory framework, AHPA, or your hazard analysis and risk analysis and the critical control points or the preventative controls that you need to put around that. So the economically motivated adulterants, specifically for some of the formats that botanicals come in, residual solvents and that foreign matter piece are all part of that, something to take into consideration when you're looking at your reference material. Dr. Brown touched upon this actually in far more detail about that inclusivity and exclusivity panels. The part that I wanted to highlight here, again, was just about the sources of variation. This was something that AOAC took into consideration 10 years ago when setting up the first Appendix K, when they were coming to the table about presenting about botanical identity, especially with the POI, or the probability of identity. So again, looking at how many variables you can include, and these were some of the ones that were included in that initial Appendix K. Constance, next slide. So this is where we are going to open up the discussion. I kind of just made a couple of bullet points here just to keep in mind what has been presented. The other parts that, in looking at the chat over the last hour and a half now, a couple of the other things to keep in mind that I thought were excellent points to bring up in this discussion is Stephen Dentali's comment about botanically derived ingredients. That is something else to consider as we're discussing this. And then the other one was, again, that plant part. So with that, I thank my fellow panelists and AOAC, and Holly, I hand the mic back over to you.
Wonderful. Thank you so much, Dr. Amarillas. And we'll want you to stay on camera, Cris, and we'll welcome Paula back too. We're going to open up the discussion to the floor now. Just a couple great points I wanted to mention before we maybe take some audience questions. Again, Cris, going right to addressing Dr. Dentali's comment that was kind of up towards the top of the chat. He makes a really good point. And so I think, first of all, I want to say, Paula, thank you so much for bringing in the kind of past history, as Cris commended you for as well. What's happened at AOAC in the past? I see many of the people on this call, including Dr. Dentali, were potentially involved in those discussions back in 2011, 2005 here at AOAC, as well as, the FDA advisory group of 1999 that was, advising the FDA on things like botanical identity. So we really want to look to all of you in the community that have that kind of historical knowledge to help inform what could be the most useful deliverable that we want to start focusing on coming out of this group. But so really appreciate all of you that were around then. Just please keep contributing to this convo, and Paula for reminding us of those past activities.
I think of the people here, it's only Daryl, Wendy, and I that were on both of the past one. I think the original working group was chaired actually by, it was John, maybe you were on it too, was chaired by Mark Roman. I did have noticed a lot of people have sort of retired, although some people are, or even those of us who are close to retirement or retired are still here and contributing. I was going to suggest that I did pull out all the documents that we had referenced in the meeting minutes, and so I'll send those as a packet to maybe Constance. And so then if they create, I don't know how you do this with these large working groups, but maybe there's like a document repository so that people in the working group can go and look and see what was there. That might be helpful if people are interested.
Yes, I'll be sending out also a follow-up email to everyone who registered for this with more information.
Okay, great. Thanks so much for grabbing that historical stuff for us to start with, Paula, and the working group. So a couple of the questions in the chat were a little bit related. So I want to start with this. We mentioned that Dr. Dentali was drawing the distinction between, taxonomy, kind of a species or a genus, a defined taxa, and a botanically derived ingredient. And I think it's related a little bit to a question that John Travis put in first. So I think what I want to make sure I get Stephen to maybe clarify his question, but I think what he's saying is that we keep in mind the difference between, we can have a dietary ingredient that is simply, ground up golden seal root. And so it is a crude plant material. It's just a root of the material, and that's what's going to go inside a capsule. In that case, maybe your specification would be golden seal root powdered or something of that nature, right? But many ingredients, many things we use as dietary ingredients are actually quite a bit more processed than that. And you can imagine us wanting to set specifications that narrow in on that a bit, right? Cris gave the example of lavender, where some of the lavender species can be differentiated by chemical profiles, is my understanding. But so if we wrote a specification that just said lavender flower, well, if we look at Herbs of Commerce 3, there's, I think, 5 or 6 species of lavender that can be included in that name, lavender, the standardized common name. So that could be any one of those 5 or 6 species and just a flower from that. And that would just be a simple specification like lavender flower. If we really wanted to get more precise, as many people do with their dietary ingredient specifications for identity, you would say something like the essential oil of the flower of Lavandula angustifolia. And that may require a different suite of tests, whether it be an orthogonal approach or something else. So just some comments there to kind of get us started. And I think actually also there was a question from John Travis, which John, I'm pretty sure you are asking a question you know the answer to, but I assume it's for the good of all, and we want to bring that into discussion. But what John asks is, what is the difference between a component and a dietary supplement? And I think, or a dietary ingredient. And I think that is, this again would just be applicable to things marketed within the United States regulatory framework. But a dietary ingredient is actually defined in the amendments, the Deshea amendments to the Food, Drug, and Cosmetic Act, right? And so this is, we've all heard these before. It's a vitamin, a mineral, an amino acid, an herb or other botanical or a constituent thereof. So those things are dietary ingredients. When they use the word component, what they mean, a component, so a dietary ingredient is one type of a component. A component is a bigger umbrella, right? So a component can be anything used in the manufacture, whether it's contained in the finished product dietary supplement or not. So there's a differentiation between a dietary ingredient and a component there. The botanical identity specification must be attached to any component. So John Travis, I want to ask you, is that why you wanted to bring up that question? Is there something else that we're missing as far as that distinction and how that relates to botanical identity testing?
So I get that's part of it, but that was not the entire question. So it just, how does one define either a component or dietary ingredients? So for purposes of identity testing, isn't the objective to identify the ingredient? And I think that's kind of what's missing in all this discussion is the regulations are identifying the ingredient, whether it is 98% ascorbic acid, whether it is crude ginkgo, whether it is Echinacea purpurea root extract with 4% polyphenols. So those are our ingredients of commerce. Is that not what we're supposed to be identifying?
So John, it sounds like you're saying kind of the same thing that Dr. Dentali is, I think, if I'm hearing you both correctly.
Yes.
Is that we can't think of botanical identity specifications as just a taxonomic thing, a botanical taxonomy question, such as, Hypericum perforatum. It really, the materials that are in commerce are much more complex, and we should write our identity specifications with that in mind, and then that will affect choosing an appropriate fit for purpose method, right? Dr. Brown, did you want to further comment on that piece?
Yeah, I think we get a little bit confused too, because, we have your specifications. There's more to it than just identity, right? I think we think of it like identity, purity, potency. We start talking about adulteration, then you're talking about purity. You're not really, sorry, not potency. I take that back. Strength or content. Sorry, Stephen. But you don't want to get too confused with purity as well. And then again, like to your point, if you're standardized to a certain level of polyphenols, then that becomes to a content. That's not necessarily identity. I mean, if you look at the spirit of where the 100% identity rule came from, it came from, don't put in digitalis by accident, right? So it really was, I think, about preventing the risk of having a misintended herb, and one that potentially is dangerous was what really sort of, pushed to have that identity rule in place in the United States. Right. So I don't know if it's yeah, I don't actually know. I mean, I think you're going to have a series of different methods that are going to tackle the different aspects of your specifications, right? I don't think you're going to have necessarily one specification that's going to say, okay, this is Echinacea purpurea. It's the root, so it's the plant part. It's an extract that proves it was extracted with this solvent, right? Like that would take another measure, and it's adhered onto this carrier, right? Would be a different measure.
So Paula, can I follow up with a question?
Please go ahead, John.
Yeah.
So I have an example. My colleagues on here from NSF, and I have been grappling with something. I'm going to use some different botanical ingredients to protect the guilty, or innocent, however we wish to look at it. Let's say we do have a product that is I use Chris's Taraxacum officinalis. It's an extract of it. One does an HPTLC, and we have a reference material, and we compare the two, and we notice and observe that while it has Taraxacum officinalis in it, the bands are considerably lighter and more less dense. We'll say less dense than that of the reference material. All things being equal, and let's also say that that we know the extraction that was performed on the article of commerce. This is where identity runs afoul and really permits adulteration of ingredients, in that we have a diluted botanical could be diluted with something that's opaque to the analytical method, but yet it spoofs the test, and one could truthfully say that, yeah, it has dandelion root in it, but it's probably adulterated with something else. So those are the kinds of things. I think there's a disconnect between regulators, industry folks, and people doing the testing. And maybe, I don't know if this is a place for AOAC to lead this discussion, to get consensus with everyone, or if this is not the proper forum for that.
No, and that, John, that's, I think, was going to be my exact follow-up, is like, and what could we do here at BIDSI to help, understand that, or help kind of get a grip around that. And I think that's what we're going to come towards. And I think we seem to be, like, some of these comments are really quite related, right?
Holly, can I just also quickly address
please go ahead, Chris.
Thank you. This, again, just really thinking of this specific call. All of us are incredibly knowledgeable in our botanical testing. Again, setting a specification depending on your regulatory framework is one thing. And this is something that, thinking about the BIDSI group and elevating this, are we going to include foreign matter as part of that? Setting a foreign matter specification, John, specifically to your question, yes, that Taraxacum extract, could be up to 75% Taraxacum officinalis. What's the other 25%? Is that on the burden of your identity test? Is that part of the approach? And so, again, just thinking about this working group, and again, the invitation for all of you, please, to come and participate in this. Where do we draw the line in that approach? Where are we coming at this in our definition, and thinking about it in this guidance document? It sounds like is what we're all using, or what we would all like to use. So thank you.
So, and following on that, something that Paula just said, and kind of related to what Chris said, is specifically supporting an identity specification is different than, of course, quality testing overall, right? So there's things like purity, limits on organic foreign matter, limits on, all kinds of other things that you're going to need different tests to support it, those specifications. And again, different types of specifications. So just focused on the identity of the ingredient. Again, it's not just the Latin binomial of a species, but it's also identity is discrete and separate from some of the other types of, things that may contribute to having an authentic or high quality ingredient. Again, the example comes up with often with like a tomato, right? So if you're going to make a spaghetti sauce, you need your tomatoes to be nice and ripe and red and juicy. If you have a tomato that's all dry and dehydrated and gross that you picked up off the ground, you still could pass some tests that say this is, a tomato fruit, but it's not a high quality tomato fruit or appropriate for the intended use that you have. So there's a lot of things that botanical identity can do, and you must support that spec. But it's different. It's quite different than a full evaluation of authenticity or quality materials. So we've got a couple hands up, and I think they're still kind of on this discussion. Let's go next to Nandu Sarma from the United States Pharmacopoeia.
Thank you, Holly. And I wanted to expand upon what Paula emphasized, that identity is one of the specification components. It does not encompass all the attributes for the quality. And just to give an example, you may have a material identified as a ginkgo, but it might still be an adulterated one. So you need to identify, and you need to also have additional tests for the quantitation of the components of the ginkgo, the terpene lactones and flavonoid glycosides and all those things, and also include tests for maybe other things like rutin and quercetin, which may be adulterants, and so on. So these are all the different components needed. So identity is very important. That in the pharmacopoeia world, we use it as a primary foundation for establishing, connecting the quality with the title, with the name. And so identity test has to pass, and then you need to test for the other quality attributes. And the 21 CFR 111 includes all these parameters. So it's really important that identity is an important component, but doesn't stand solely by itself. So it has to be considered in the context of all the other quality attributes. Thank you.
Nandu, thank you so much for that. Clearly, Nandu and his colleagues at USP create these really robust monographs. And this goes back to what Cris was saying as well about kind of an orthogonal approach to establishing identity of certain ingredients. Sometimes one test is not enough, right? And say you have a test that tells you with 70% confidence, say that it's this particular species or this particular plant part. What the United States Pharmacopoeia often does in their monograph approach is add a series of tests so that you actually have maybe one test might only give you 70% chance of a correct identification, but by adding another test, you can up that into the 90s or above. And they usually look at two different diagnostic parameters, right? So Nandu, thank you so much for those comments. And Nandu's colleague, Maria Monagas, also puts in the chat here a comment about the difference between raw botanical material and processed botanical materials. And you're exactly correct, Maria. We totally agree. They require different tests and different acceptance criteria. And that's another thing too. One botanical identity test does not fit, is not appropriate and fit for purpose for all different materials. So I'm going to go next to Alchemist Labs. I'm not sure who's running the platform there for Alchemist Labs, but your hand has been up. Could you reveal yourself and go ahead with your comment?
I will reveal myself. This is Sydney. Hi, Sydney Sudberg. Can you hear me okay?
We got you. Go ahead, Sid. Thanks.
Thanks. So yeah, the points were very well made, Nandu and you, Holly, and several others, about the difference between identity and quality. while we can easily fail something based on its lack of, I'll say, quality, could be due to John Travis's point with respect to concentration, or he called it density. The goal, though, of an identity analysis is identity. It's not my job or anybody's, unless, you know, look, if you're buying something, you have to know that if you get what you pay for, hopefully. If the quality of the material is unidentifiable, it should not be passed as that particular botanical. But if it's poorly, if it is of such a poor quality and you can still identify it, you've done your job. You know, beauty's in the eyes of the beholder and quality is in the hands of the manufacturer. Just about every manufacturer has a different version of, you know, whether it's ginkgo or echinacea or ginseng. And the goal is to be able to identify it. So, I mean, that should clarify, I mean, at least from the way we approach it, that you identify something, and it's not my job to tell them that this stuff is crap or any variation of that. That's their decision. Years ago, when NIST did their PT for botanical identity, they had difficulty in being able to define. And what I just spoke about really only mostly primarily applies to powdered extracts. And when they gave, and it was done for ginkgo, and many of the extracts, if not all of them, they weren't native extracts, so they were quote unquote diluted or extended with fillers, etc. And when people passed it, they were a little bit like perplexed, because it isn't just ginkgo, it's an impure material, and you didn't catch that. But by definition, what is sold in industry as, let's say, any powdered extract, it's a given that there's going to be some other material there. So how appropriate? You know, again, this is the formulator or the manufacturer, the retailer of this has to make that decision. Quality is not talked about or addressed in the government regulations in 21 CFR. I think that's all I wanted to say about this. Thank you.
Yeah, I just wanted to say, you know, I agree. That's what I was sort of trying to say. Like, what we're trying to talk about is identity methods, not quality methods per se, right? And it also doesn't necessarily mean that we're talking about adulteration, but that does tend to be how we trend when we're trying to find the identity. We don't just say that this is echinacea, we say it's echinacea because it's not these other things, right? That's where I think it gets a little bit complicated.
Well, that's why in some of our reports, we would say, I used to say when we first started, confirms identity. And then when we were doing work for NSF, they came back and said, well, can you really say that? And as I thought about it, and I agree, confirming identity would be the taxonomic identification. Confirm the identity. It complies, or it conforms to the taxonomic key that I'm making the identification by. But once you have some type of extract, it has characteristics or it's similar. You tell me what words work the best. I mean, I rely on people's feedback, but it's important to recognize that we're not quote unquote confirming identity. We're saying this is derived from, that could be something, but I don't, you know, I think most people are expecting to hear, oh, this confirms identity. This is the material that they say it is.
Sid, thank you so much for that. Sid's been in the business for many, many decades now of looking into botanical identity, and in fact trying to confirm or support identity specifications for materials in commerce. Paula, your point is so well taken that supporting an identity spec is only one part of an evaluation of the quality of a material, right? And so I want to get to one other question in here that I find a little troubling in the chat before we move on. I see Cris with her hand up, and Nandu, not sure if your hand is a legacy one or if you have another comment, we'd welcome you. And Pam Coleman, I see your hand up. I'm not sure if that's intentional. If it is, we're coming to you next. I see a question here in the chat from Michael L. And Michael, maybe you want to identify who you are, your company. I'm not sure who you are, Michael L. But what Michael says here in the chat is, quick question. If we don't necessarily have the ability to test, I assume he means with complex identification methods, would we need to verify each individual raw material, like let's say with third-party testing or in-house, or could we cover that identification via testing the finished product that these raws are going into? So what I want to say, Michael, is first, I am not an attorney. This does not constitute legal advice, but you should talk with your attorney about this most definitely, because what seems to be very clearly laid out in Part 111 is that you must set specifications on components as well as your finished product. There's actually two different sections, right? So you need to set all of those components or all of those types of specifications that you determine necessary on each component. And the one that you must test yourself, either sending it to a third party or doing in-house, is identity. So you cannot just skip doing identity evaluation of your components. You have to do it in each component as well as in a finished product, which presumably the finished product would have a different identity spec, as we were just speaking of. So, okay, so that's great. And Michael L., please, be in touch. We can continue to talk about this if you like. Sid, your comments are so well taken. And I think, again, just to reiterate what Sid and what Paula said is, these are in the United States regulatory system, these are manufacturer decisions. So a third-party test can show you some results, can show you this or that, but also those results are only as meaningful as your specification and how it's written, right? Cris, do you have some further comments on this topic? Please go ahead.
I do, and just kind of elevating this back to a BIDC discussion. I mean, all of us are very passionate about not just the identity, but the quality that's going into the dietary supplement marketplace. I think this is kind of what is the stumbling point when we're looking at identity. And Sid, thank you so much for your comments, because this is the point. It's like, how do you choose the best approach when it comes to identity? And whether it's spent lavandula, you might be able to, it goes back to that fit for purpose as well. Are you going to take that spent material, whether it's, used mark that's going back on, or used plant material after the quote unquote active or the major constituents or the constituents of interest are extracted, and that material comes back onto the marketplace? There's maybe one identity test, or maybe that would pass a certain type of identity testing, like a morphological identity test. Whereas if you're approaching that same material with a chemical test, if you've already extracted the chemicals out of it, it's not going to pass that identity test. So I think this is where we, as this joint community, all come with our passions about, is identity just a standalone identity piece, or is it kind of loosely threaded or maybe very much embedded into that quality piece? Is that foreign matters part of your specification under 21 CFR 111? Is that just as much part of the identity actual test as it is just a purity test? And I think this is where we didn't have that insight when DSHEA was first passed, or even 10 years ago. This is becoming a much more complex marketplace. So just thank you, Sydney, for your comments, and Paula for yours on that piece too.
Thanks so much for that, Cris. So you guys, we only have a few minutes left. I mean, my gosh, we're all such nerds in the best way. We could sit here and talk about botanical identity specs and methods of evaluation for another hour. What we really want to bring out from you guys in the last minutes we have is, what are we going to do in BIDSI? What should our first project be? One of the last projects we did within the newly established BIDSI was standard method performance requirements for pure lizidine alkaloids. So that was a real specific project. The next thing that's kind of come down the pike, preceding this, prompting this talk here today is that botanical identity is something that the industry stakeholders, that means you guys here on this call, would like AOAC to tackle as an initiative. So what we're looking for is, we're ready. We obviously have a lot to talk about. There's a lot of different challenges. What we want to understand is what's going to be the most helpful to do first in this working group. So maybe I would ask if maybe Kate Mostovska from AOAC or Constance wanted to come on and kind of add something here about what we'd like to get from this group, or how we might get those comments. We're of course open to any kind of email follow-up to this discussion, but we really want to get a very well-defined botanical or deliverable around this botanical identity verification to try to just have a really nicely defined project that we'll do under botanical identity in this initiative. Constance, thanks so much for putting that up. And you can see, we've got Eurofins, which is Dr. Amarillas' company, as well as Alchemist. We just heard from Dr. Sudberg, Herbalife and Nature's Way. I think I saw at least someone from Herbalife on the call today. So these are companies that have already dedicated support that, know that whatever we come up with as a first deliverable will be something that they want to support. So we are looking for financial support. And with financial support does come advisory rights, I believe. I don't know if I'm explaining that exactly right. Kate, maybe you could comment a little further on that. But as a supporter, you will have, you will be a member of an advisory panel that will kind of advise the initiatives that will happen within BIDSI. So, Kate, wonderful.
Just quickly jump in. I know we have just a few minutes to go, but thank you so much for framing the discussion. I know there's a lot of challenges, right? So, and we need to look at some priorities. So that's why we are, as the first step, as the next step, basically, we want to populate this advisory panel, because that advisory panel will also provide directions to the next steps in this initiative. So we are looking for additional supporters. Thank you so much, Alchemist, Eurofins, Herbalife, and Nature's Way, already providing support and committing support for this initiative. And once we have enough support, basically, to launch this initiative, we will then have the next set of basically, let's say, meetings with the AP and put together the priority basically list for the working group to work on. This really was a really great discussion, which helped us get a lot of inputs. And maybe if you go to the next one, Constance, where we want to invite you to join us at the mid-year meeting, where we will continue in some additional discussions, and we'll have again, hopefully Paula and Cris come and join us again, and again lead it, figure out what's really important, because there were too many points, I would say, right? I mean, which people need to tackle. So we need to start with the priority which makes sense. And again, we'll be looking at the advisory panel direction, right? Where to lead basically the first steps in this development, which will most likely be a guidance development, right? As you guys have been discussing.
Thank you, Kate. And I would just like to take a moment to give a thank you to Holly, Cris, and Paula for agreeing to help spearhead this effort, and to all of you for joining in today with this wonderful discussion. And hopefully we can continue this. And with that, have a wonderful rest of your day. Thank you so much.
Yep. Thanks so much, everyone. Please be in touch. We need your feedback.
Thank you all.
Thank you.
Thank you.